I'm by name Amajimo Ibrahim, the Group Managing Director of Gima Excellence Schools, the author of Laboratory Manual of Physics Practical in the year 2010. We are going to look at physics, course title, current electricity. Physics, course title, current electricity. What did I call it? Current electricity. Current electricity. What do you understand by the word current electricity? Current electricity is the rate of flow of charge around the potential difference in an electric cycle. That is, an electric current is defined as the rate of flow of charge around the potential difference. Potential difference B in an electric cycle. Mathematically, we can express it. Mathematically, our current I is equal to rate of flow of charge divided over potential difference. That is K over V. K is measured in coulomb, V is measured in volts. Therefore, the SI unit of electric current is ampere. Electric current is measured in ampere, or it is expressed in ampere. That is what we call the unit of an electric current. Then we have to look at Ohm's law. Scientists known as Ohm formulate the relationship between a metallic conductor and the potential difference between the ends of the conductor. He formulates his laws as follows. Ohm's law says that Ohm's law says that provided the temperature and other physical conditions remains constant. A steady current flowing through a metallic conductor is directly proportional to the potential difference D between its ends. Ohm's law says that provided that the temperature and other physical conditions remain constant, the steady current flowing through a metallic conductor is directly proportional to the potential difference between the ends of the conductor. So we are going to show the mathematical expression relating to what? Ohm's law. Mathematical expression relating to what? What did I call? Ohm's law. Mathematically, Ohm's law, that is current I, is directly proportional to the potential difference. That is, mathematically, our mathematical analysis, we can say that V is directly proportional to I. V is now equal to IR, where R is the resistance known as the constant of proportionality. Known as constant of proportionality. Then we move further to resistor in parallel. Resistor can be connected in parallel. It could also be in series connection. When resistor is connected in series, it means that such resistor potential difference is connected across each resistor. For example, let's consider a resistor, an electric current having a resistor connected in series as follows. We have resistors in series. Resistors in series. Resistors in series. Resistor connected in series means that the resistors are connected along a straight line. We have, let's call this place to be R1. This is R2. This is R3. This is series connection. This is resistors in series. Let's call this one figure 8. Call it figure 8. Then we have V1, V2, V3. Then in series connection, we have one electric current, one current I, supplying resistor R1, R2, and R3. Then, but each resistor has its own potential difference. This can be proved as from the diagram above. From the diagram above, then we can say that V is equals to V1 plus V2 plus V3. Total V, isn't it? Total V is equals to V1 plus V2 plus V3. But V is equals to IR. Let us call this one equation 1. Replace IR for V in equation 1. Our equation 1 is V equals to V1 plus V2 plus V3. So anywhere we see V, call it I1. That's according to Ohm's law. Then we have IR is equals to I1, R1, or IR1 plus IR2 plus IR3. Then I is common to both sides. Let's factorize. We are factorizing. IR is equals to I into R1 plus R2 plus R3. We divide both sides by what? I. We divide both sides by I. We have IR all over I equals to I into R1 plus R2 plus R3. Divided by I, we cancel I. Therefore, resistor in series, R equals to R1 plus R2 plus R3. This is what we call the series connection. Then let's look at the parallel connection. Resistors connected in parallel. When resistors are connected in parallel, it means that each resistor has its electric current. Each resistor has its what? Electric current, but one potential difference. Let's look at this. Resistor in parallel. Resistor in parallel. Now resistors in parallel. We have to look at the resistors in parallel as follows. We have resistors connected in parallel. This is parallel connection in an opposite direction. We have something like this. This is parallel connection. From here, we have resistor 1, we have R2, we have R3. Then we have total R. Total what? R. So we have total R. Then we have our total R is here. Then resistor. We have total current I. We have I2, we have what? I3. Isn't it? Total current is equals to sum of individual current. That is, total current from the diagram above, total current is equal to sum of what? I1 plus I2 plus I3. So this implies that our I is equals to I1 plus I2 plus what? I3. That's in parallel. So, but according to Ohm's law, V equals to what? IR. Anywhere we see, we can divide both sides by what? R. So I equals to what? V all over R. Call this one equation 1, call this one equation 2. Isn't it? Let's call this one figure B. So from figure B, we can now replace, anywhere we see I in equation 1, we can replace V all over R. That is, I equals to, let us recall our equation 1, I1 plus I2 plus what? I3. V is our equation 1. Anywhere we see I, call it V over R. That is V all over equals to V all over what? R1 plus V all over R2 plus V all over what? R3. Then let's factorize. What is common to both sides is V. So V all over R is equal to V into bracket 1 all over R1 plus 1 all over R2 plus 1 all over R3. This V will cancel V. So what is our resistor in series? In parallel. Rather, our parallel, that is R, 1 all over R is equal to 1 all over R1 plus 1 all over R2 plus 1 all over R3. This is what we call the parallel connection. Let's look at one example before we go. Then, for example, find the resistor. Find the equivalent. Find the equivalent resistor in the diagram below. We have something like this. This is 2 ohms resistor. This is another 2 ohms. This is what? 3 ohms. This resistor is connected in what? In series. So, solution. We have, because it is connected in series, R will now be equal to R1 plus R2 plus what? R3. R will now be equal to, that is 2 plus 3. Everything in what? In ohms. So 2 plus 2, that's 4. Plus 3, that is what? 7 ohms. That is what we call the parallel series connection. This is series. Then let's look at one example in parallel connection. One example of resistor connected in parallel. Example of resistor, parallel. Parallel connection. Parallel connection. Resistor in parallel connection. We have something like this connected in parallel. We have resistors connected in parallel. Let's look at one example before we go. So we have 2 ohm resistor. We have 2 ohm resistor. Let's assume we have 2 ohm resistor. In parallel connection, we have, to get this, 1 all over R equals to 1 all over R1 plus 1 all over R2 plus 1 all over R3. So we have 1 all over R equals to 1 all over 2 plus 1 all over 2 plus 1 all over what? 2. You find the what? The LCM. 1 all over R equals to 2 divided by 2, 1 times 1, 1. 2 divided by 2, 1 times 1, 1 plus 2 divided by 2, 1 times 1. We have 1. Then, what do we do? 1 plus 1 plus 1 plus 1. That is what do we have? We have it to be what? To be 3. So 1 all over R is equals to 3 over 2. We cross multiply. That is 2 times 1 is equals to 3 times R. So we have 2 is equal to 3 times R. That's 3R. What do we do? Divide both side by 3. Divide both side by 3. 3 cancel 3. Therefore, the combined resistor is 2 all over 3 ohms. So this is where we are going to stop today. In our next class, we are going to look at what is used to measure an electric current, the whistle brick, the meter brick, the galvanometer, the ammeter, and others. Then we are going to equally look at combination difference between resistor, resistance, resistivity of the material, in direct proportional to cross-sectional area of the wire, and inversely proportional to the what? So the square of the distance R of the material. So this is where we are going to stop today. Do not forget to click on our channel. There, do not forget to click on the red button. Where what? Jima Excellence School. Till I come your way again. Many thanks for listening. Goodbye.